So for this video, we're going to be going over the different measurement corrections and distance corrections that you'll be using in surveying. And these corrections just account for different anomalies that occur when you're measuring distances. And I just figured it'd probably be best to just stick all the corrections, at least the most important ones that you'll be using, in one place into the study guide, so you can just have them, all in the same place, and you know exactly where to go to find these corrections. So the whole purpose of having these corrections is to be able to determine the actual distance that was measured rather than the distance that you measured because that wasn't correct because of some sort of anomaly. And so your actual distance is going to equal your measured distance plus the sum of all of your corrections that you have. Now, in the example that I gave you, in like the written example, I only did these corrections one at a time. However, there may be situations where you might have a length and a temperature correction that you have to account for. So you just take both of those corrections, add them together, and then plug them into this equation. So sometimes you have a combination of corrections that you need to take account for, and it's not just going to be one correction at a time, but it's going to be the sum of all of those corrections. So the first correction that we're going to talk about is going to be your length correction. And this is for if, say you have a measuring tape that is supposed to be 100 feet long, but in actuality, just because of overuse or, you've had it for a long time, whatever the reason, the actual length of your measuring tape is either more or less than this 100 feet here. And so this equation here will correct for that anomaly in the actual length of your tape. Because if you think that your tape is 100 feet and you use it, so many times and you measure a distance of, say, 5,000 feet, but then come to find out your tape is only 90 feet long, that actual distance, you may have measured it to be 5,000 feet, but the actual distance is a lot less because your measuring tape is actually less. So you're going to use this correction factor here to account for that. And so that's going to be your correction factor. And it's going to be equal to L minus L prime divided by L prime all times L. And so I've defined those for you below. So your L is the actual length of the tape. So if you had a tape that you thought was 100 feet but it was actually 99 feet, that L is going to be this 99 feet, whereas L prime is going to be that assumed length, that 100 feet of what you thought it was going to be. And then, of course, your capital L is going to be your measured distance. So in the example that I was talking about before, that would be your 5,000 feet. So another correction that you're going to have to account for is temperature. So oftentimes these measuring tapes are still, and when they heat up, obviously they're going to expand and become longer. Or if it's colder, then they're going to contract and the measuring tapes are going to be shorter than what you actually think they're going to be. So you're going to go ahead and use this correction equation, and that's equal to alpha times the quantity T minus TS all times L, where again L is your measured distance. alpha is this coefficient of thermal expansion, and it's 6.5 times 10 to the negative 6 per degree Fahrenheit, and that is going to be for steel, which your measuring tapes are more likely than not going to be steel. So you're going to use that value always for alpha. And then T is your ambient temperature, and TS is your standardized temperature for that tape. So oftentimes your tapes will come with a standard length and temperature. So it'll say this tape is 100 feet at 68 degrees. And so what that means is the length is going to change as your temperature changes from 68 degrees. But at 68 degrees, this tape is 100 feet. So this 68 degrees here is going to be your standardized temperature. And then whatever the ambient temperature outside is going to be this just T. So TS is going to be your standardized temp, which is given to you by the manufacturer. And then T is going to be the temperature measured outside. And then finally, the last correction we're going to look at is for alignment or slope. And that is going to be equal to negative V squared over 2S. And so CA is always, always, always going to be negative. That's important to remember. And so V is going to be this difference in elevation or alignment, or the difference in slope in degrees. So if you are measuring on some slope, then it's going to be this incline angle here. And then S is going to be 100 feet, and your CA is going to come out as some value per 100 feet. And so you're going to take that value and times it by MD over 100, because again, it's per 100 feet, so you want this 100 to cancel with this 100 here. And then, of course, add that to your measured distance, and that'll give you your actual distance. And really, your corrections are as simple as that. You just find your corrections, add them to your measured length, and then you have your actual distance. If you do have any questions about this, feel free to visit our homework help page or our tutoring page, and we'll be able to provide additional help for you there.